All right, we're going to work through the associated handout with this lecture. So I strongly recommend pausing this video, trying to work through the entire worksheet, answering as much as possible. If you can't answer everything, that's fine, but you'll certainly get more out of it if you attempt it before watching this video. Okay, so I'm going to work through this. So we have a study that's being conducted to see how well children understand TV commercials. 300 randomly selected children were selected, and they watched a series of TV commercials and then asked questions about the commercials, basically seeing whether they understood the commercial or not. Okay, so we've defined a couple events here. So event A is that the child understood the commercial. Event B is that the child is 8 years old or older. Okay, so let's calculate the probability of event A, that the child understands. So understand is this row, and we have our row total of 189. So we have a total of 300 subjects. So our denominator here is 300. Out of the total 300, how many of them understood? And we have 189. So 189 out of 300 is 0.63, or equivalently 63%. Okay, event B, the child is 8 years old or older. So 8 years old or older, so that would be 8 to 10 and 11 to 12. And we have both of those column totals. So we have 99 for this group and 102 for this group. So probability of B, we still have 300 total people, so 300. And now we're going to add the 99 plus the 102. So that is 201 over 300, or simply 0.67, or 67%. Of course, if we wanted, we could also find probability of A complement, which would be 1 minus probability of A, or 1 minus 0.63, which would be 0.37, or 37%. Same thing with probability of B complement. 1 minus probability of B, which would be 1 minus 0.67, which is 0.33, or 33%. Okay, probability of A and B. So we have a child that is at least 8 years old, and they understand the commercial. Okay, well, we know that understand is this row. That's event A, and we want to intersect that with event B, which is this column and this column. And we can see where these intersect would be here and here. And so the probability of A and B, we still have 300, but we have 60 plus 87. And so this is equal to 147 over 300, or 0.49, or 49%. Okay, probability of A or B. Okay, well, we can use our additive rule, which is the probability of A plus the probability of B minus the probability of A and B. And we've just found all of these, so we have 0.63 for A, right? 0.63 for A, and then 0.67 for B. So 0.63 plus 0.67 minus A and B, 0.49. So minus 0.49, which is 0.81 or 81%. Actually, I'm going to move these to the same row just to save me some space. Because alternatively, we could have just done this directly, where the probability of A or B, if we wanted to say A or B, so we would have understand, so 42, 60, and 87, plus B, which is the 39. I'm not going to double count the 60, and then the 15, and I'm also not going to double count the 87. So if I wanted to, I could have just written this as 42 plus 60 plus 87 plus 39 and 15. We're still dividing by a total of 300. And this would be 243 over 300, which is still 0.81 or 81%. Okay, A given B. So we know that this is equal to the probability of A and B divided by the probability of B. Okay, well, we found the probability of A and B to be 0.49. So 0.49 divided by the probability of B, which we found to be 0.67. So divided by 0.67. And I get a 0.73 or 73%. Okay, probability of D complement. Okay, well, use a new color. Okay, green. So D complement. So D is child is not 11 to 13. So if they're not 11 to 13, well, so perhaps we start with calculating the probability of D. So not 11 to 13 would mean they're either 5 to 7 or 8 to 10. So that'd be 99 to 99. Or sorry, just 99 and 99. So here we have 1 minus the probability of D, which would be 1 minus 99 plus 99 over 300. So this is the same as 1 minus 198 over 300, or 1 minus 0.66 should be 0.34 or 34%. Or it might make more sense here to just calculate this directly. So probability of D complement. So if D is not 11 to 13, D is not 11 to 13, oops, then not that would just be the child is 11 to 13, which there are 102. So we could say this is just 102 over 300, which is 0.34 or 34%. This one was a little funky just because we were dealing with this said it our event D here was a negative, so then we're having a double negative here, which means it's just 11 to 13. Okay, what's next? Now we want to know, are A and B independent? Okay, well, we know that the probability of A and B was equal to 0.49. We found that up above. And we want to see if this is equal to the probability of A times the probability of B, which is 0.63 times 0.67, which is 0.42. So 0.42, which is equal to the probability of A times the probability of B. And we note these are not equal to one another. The probability of A and B is not equal to the probability of A times the probability of B. So are these independent? No, because of the reason we just gave. Because probability of A and B is 0.49, which is not the same as the probability of A times the probability of B, which is 0.42. But alternatively, we also could have just checked probability of A given B, which we found to be 0.73. And we would see this is also not equal to 0.63, which is our probability of A. Right, probability of A is 0.63, which is not equal to the probability of A given B. So these are not independent. We would say these events are dependent. Are they mutually exclusive? And that, of course, is no, because we found that the probability of A and B to be 0.49, which is not 0. Okay, let's move on to number 2. Consider choosing a random sample of size 2 from the following people: Abby, Leah, Rebecca, and Joshua. And here order doesn't matter. So write down the sample space of selecting 2 people from this group of 4. Okay, well, let's start with Abby could be paired with Leah, Abby could be paired with Rebecca, and Abby could be paired with Joshua. Leah could be paired with Abby, but we've already accounted for that. Leah could be paired with Rebecca, and Leah could be paired with Joshua. And then Rebecca could be paired with Abby, but we've already accounted for that here. Rebecca could be paired with Leah, but we've already accounted for that here. So Rebecca could be paired with Josh. And then we've already matched Josh with all 4 people. So this is our sample size, or our, what should we say? For part B, we want to find the probability that Leah and Rebecca are chosen. So we are interested in the probability we get Leah and Rebecca. And these 6 outcomes represent our sample space. So there are 6 possible ways to select 2 people from a group of 4. So if we calculate the probability we select Leah and Rebecca, well, there are 6 total ways that we can select these people, right? 1, 2, 3, 4, 5, 6. But there's only one way to select Leah and Rebecca, which would make our probability 1/6, which is also 0.167 or 16.7%. Let me move these over here. Part C, find the probability that Joshua is included. Okay, well, we can match Josh with Abby. Josh could be paired with Leah, or Josh could be paired with Rebecca. So the probability that we get Josh, we still have 6 total outcomes. How many of those 6 is Josh included in? And that would be 3. So 3 out of 6 would be the same as 1/2, 0.5, or 50%. Okay, moving on to number 3. So we are told in the Digest of Education Statistics, according to this document, 84.8% of students attended public post-secondary schools. So let me just go ahead and redefine public as the event A. So probability of public, we'll call the probability of A. And let's call this, and we are told that 84.8% of students attend public. 23% of students attend a 4-year university. So I can call the probability of 4-year the probability of B. We are told this probability is 0.177. Or I'm sorry, that's not right. 23, 0.23. Okay, and then we are told that 17.7% of students attend both public and 4-year universities. So here, both, so this would be probability of A and B. We are told that this is 0.177. So what percentage of students attend either public or a 4-year university? So probability of either. So this would be the probability of public or 4-year. So probability of A or B. So let me first write this using our notation. So probability of public or 4-year, which I could also write as the probability of A or B. So using our formula, this would be probability of public plus the probability of 4-year minus the probability of both. Using our alternate notation, this would be the probability of A plus the probability of B minus the probability of A and B. We already have all of these values. These were all given to us. We were told that A was equal to 0.848 plus B, which was 0.23, minus both was 0.177. And if we put that into our calculator, we get the value 0.901, or 90.1%. So we can see sometimes it might be easier to rename events as just A or B, so that it might tip us off to which formula that we should use. Okay, and then finally, number 4, consider a person who purchases from 2 different manufacturers a TV and a Blu-ray player. So suppose that 1% of TVs that are manufactured do not work properly. So 1% of TVs don't work properly. So that's where I write the probability of a TV not working is 0.01. And then 2% of Blu-ray players don't work. So that's where I've written the probability of Blu-ray is 0.02. Okay, suppose that these 2 events are independent. That is just given to us. So find the probability that both the TV and Blu-ray player don't work. So we buy a TV and we buy a Blu-ray player. What's the probability both do not work? So I'm going to say this is the probability of TV and Blu-ray player. And we are told that these two events are independent. So if they are independent, we know that we can just write this as the probability of TV times the probability of Blu-ray, which would be equal to 0.01 times 0.02 is 0.0002 or 0.02%. And again, we can do this by independence.